how's it going, guys? Today in this video, we're going to be going over Module 15.1, Day 1. We're going to be defining and evaluating a logarithmic function. So a logarithmic function is actually the inverse of an exponential function, is everything we did in Module 13. And because there are inverses, that means we can write an exponential function in terms of a log, and we can write a log function in terms of an exponential. So in other words, if we have an exponential in the form b raised to the x equals a, we can rewrite it as a log in this form of log base b of a equals x. And that's all dependent of b as long as b is greater than 0 and b does not equal 1. So on this slide here, what we're going to do is we're going to fill out this table and we're going to get some practice rewriting exponentials as logs and writing logs as exponentials. So if we have 4 cubed equals 64, we can rewrite this as log base 4 of 64 equals 3. The base of the exponent is still going to be the base of the log, and all we really do, or how I like to think about it, is we're going to take the exponent and we're going to separate it away from the exponential, and then we're going to put it back together and we're going back into the exponential. So for the exponential equation, we have 4 to the third equals 64. Now 4 is always going to be your base, since it's the base of the exponential, and we take the exponent away from it to the other side of the equation. So it becomes log base 4 of 64 equals 3. And then for the next row, we have log base 5 of 1 over 25 equals -2. So it has the log has a base of 5. That means the exponential will also have a base of 5. And now when we're going into an exponential, we're putting the exponents back into the base of the exponential. So that -2 is what becomes the exponent of 5. The number that's away from the exponent becomes the exponent when we put it back into the exponential form. So 5 raised to the -2 is 1 over 25. And now 2 over 3 to the p equals q. We can rewrite this as log of 2 over 3 of q equals p. And then for the fourth row, we can rewrite that as 1/2 to the n power equals n. And for the next 8, I want you guys to pause the video and try it out yourself, because converting between exponentials and logs can be a little confusing at first, but just like with everything else, you need practice with it to get better at it. So pause the video, try it yourself, look what I did, look at the equations on the previous slide in your notes, and try to figure these out. And in a few seconds, I'll post the answers. All right, so this is what you should have gotten for the rest of this table. So double check your work with what I got. If you got something different, relook at the equation that we talked about in the previous slide and see what you did wrong, and try to compare what you did with what I got, and try it again, all right? But now we're going to keep on going, and now we're going to use what we just learned of how to convert between exponentials to logs and logs to exponentials to actually figure out how to solve logarithmic functions. So if we're given f of x equals log base 10 of x, and we're told to find f of 1000, that's telling us that x equals 1000. So what we're going to do is we're going to plug in that x into this log that we're given, and we're going to set it all equal to 1. So we get log of base 10 of 1000. We're plugging in our x, and that's all equal to y. So now we have our log function put together. We plugged in our x, we set it equal to y. We're going to convert it into an exponential form. And that's because we can't really solve it as a log. We don't really know what to do with it. So what we're going to do instead is we're going to convert it into an exponential where we can actually solve it out. So if we convert it into an exponential function, we get 10 to the y equals 1000. And once you convert it into exponential form, what we want to do is we want to make sure that both bases on both sides of the equal sign are the same. So right now we have a base of 10 and a base of 1000, but that 1000, what that 1000 is the same thing as 10 to the third. So we have 10 to the y equals 10 to the third. 10 to the third power is 1000, so it's the same thing. We're just rewriting it So we have the same base on both sides of the equal sign. And once we have the same base on both sides of the equal sign, we just set the exponents equal to each other, and we get that y equals 3. So that's for f of 1,000. Now we're going to do the same thing for f of 0.01. So we're going to plug in our x. So we get log of base 10 of 0.01 equals y. And once we plugged in our x and set it equal to y, we're going to change this into exponential form. So we get 10 to the y equals 0.01. So we plug in our x, set it equal to y, change it to exponential form. Now the next thing we need to do is we need to make sure that we have a base of 10 or the same base, on both sides. So 10 to the y, that's going to stay the same. We're not going to mess with it. With that 0.01, if we change it to a fraction, it's the same thing as 1 over 100. And 1 over 100 is the same thing as 1 over 10 squared. But at this point here, we see we have 10y equals 1 over 10 squared. We have a 10 on both sides of the equal sign, but we want 10, not 1 over 10. So we need to change, or rather, we need to get this 10 squared to the top of the fraction. If you guys remember from a few modules back, when we talked about the rules of exponential, the properties of exponentials, if we want to move an exponential from one side of the fraction to the other, you change the sign of the exponent. So to go from the bottom of this exponent to the top, we need to add a negative to the 2. So 1 over 10 squared is the same thing as 10 raised to the negative 2. You change the sign, and you can move it to the other side of the fraction. From bottom to top or top to the bottom, it doesn't matter, as long as you change the sign. So now that we have the same base of 10 on both sides, we can see that y equals negative 2. And now for the last one, f of the square root of 10. So we'll plug in our x, so log base 10 of the square root of 10 equals y. And now we're going to rewrite this as an exponential. So we get 10 to the y equals the square root of 10. And the square root of 10, we can rewrite as 10 to the 1/2. And now that they both have the same base of 10, we can set the exponents equal to each other. And we get that y equals 1/2. All right. So let's go on to the next page. On number 2, we're going to go, we'll do the same thing. So we have our function that they gave us, f of x equals log of base 1/2 of x. And we need to find f of 4 first. So that's our x value, x equals 4. We're going to plug that in, just like we did before, and set it all equal to y. Plug in your x, set it equal to y, and now we're going to change it into exponential form. So once we change it to exponential form, now we need to make sure that we have the same base on both sides. So on the left side, we have 1 over 2 all to the y power, that equals 4. So 4 is the same thing as 2 squared. But we need a base of 1/2, not 2. So what we're going to do the same thing we did before. I'm going to change that exponent to a negative and put that 2 to the bottom of the exponent, bottom of the fraction. So you get 1 all over 2 to the negative 2. And 1 all over 2 to the negative 2 is the same thing as 1 over 2 to the negative 2. And that's because we have a 1 on the top, and 1 raised to any number is just going to be 1. So you can factor out a negative 2 from the exponent, and that's the exact same thing. So in this case, y equals negative 2. So let's go on to the next problem. We have f of 1 over 32. That's our x value. So we're going to plug that in. So we have log of base 1/2 of 1 over 32 equals y. Plug in an x, set equal to y. Now we're going to change it into exponential form. So 1/2 to the y power equals 1 over 32. So 1 over 32, that's the same thing as 1 all over 2 to the 5th power. And because we have a 1 on the top of the fraction, we can factor out that 2. Or sorry, the 5, not the 2. Or factor out the exponent. So we get 1 over 2 to the 5th power, or y equals 5. And now for our last problem of number 2, we have f of 2 root 2. So our x equal to 2 root 2. So we have log of base 1/2 of 2 root 2 is all going to equal y. Plug in x, set equal to y. And now we're going to change it into exponential form. So we get 1/2 raised to the y equals 2 root 2. Now that we have an exponential form, we need to make sure we have the same base on both sides. So for the 2 root 2, we actually have two different numbers being multiplied together, 2 and square root of 2, and I want to combine them. All right, I don't want to deal with two different numbers on one side of the equal sign, so I'm going to combine the two together, so I only have to deal with one. And to do that, I'm going to rewrite the square root of 2 as 2 to the 1/2. And then 2 is also the same thing as 2 raised to the 2 over 2. And now that we're multiplying two exponents with the same base, all I have to do is add the exponents. So 2 times the square, 2 times the square root of 2, or 2 times 2 to the 1/2 is the same thing, will give us 2 to the 3 over 2. And that left side should say 1/2 to the y power, not 2. So like we did before, we have a 2, but we want a 1/2. So we're going to take the exponent of 2 and put it on the bottom of the fraction. And change the exponent into a negative. We don't need to put it on the bottom. We can take it right to the top or right outside. So you get 1/2 to the y power equals 1/2 to the negative 3 over 2, or just y equals negative 3 over 2. For number 3 and number 4, I want you guys to work on that on your own. We post a completed key on Canvas. You can double check your work there. But it's going to be the exact same process we did here. It's going to be a little different numbers than we're used to. I think it's a 7 and a 3. But it's going to be the same exact process as we did here. So you need to rewatch the video, do it, and hopefully this video helped, guys.